Hi all, thanks for watching this video. Welcome to Big Data Hadoop demonstration. So before we jump into our today's agenda, let me clarify one thing here. I'm not going to take you that boring PPTs. I'm not going to go through the site slide by slide to explain about the topics that we are going to discuss in this demonstration. Mostly I'm going to use the notepad to explain the topics that we are going to discuss here. I'm going to write it down very clearly on the notepad so that you will understand what's going on with each and every topic that we are going to discuss. Okay, so let's go ahead and jump into our today's agenda. I'm going to briefly introduce about myself. Then we are going to discuss about what is big data. In this demonstration, we are going to discuss very thoroughly what is big data, the big data related issues. All of a sudden from last decade, why we started talking about the big data, even though we have the data from last 15-20 years, all of a sudden why we started talking about the big data. Then what and all issues or challenges that we have using our existing computational techniques. It can be, when I say existing computational techniques, probably you can take it as a Java, .NET, mainframes, or any business related, intelligent related tools. It can be Tableau or any data warehouse related tools, or it can be any data warehouses, probably your MySQL or DB2 or Oracle. Why we are not able to deal, why we are not able to address the big data related issues using these systems. And also we are going to discuss very thoroughly the big data definitions using some of the V's actually, which is very important for our interview and as well as for the certification purpose. And also we are going to see what is Hadoop. Okay, why Hadoop was born. Okay, what is the relation between big data and Hadoop. Okay, and also we are going to discuss very thoroughly what is Hadoop architecture, based on what architecture Hadoop is going to work, so that we are going to address the big data related issues. Then why we have to use Hadoop when you have Hadoop kind of technologies in the market. Exactly, we are going to discuss the features of Hadoop, what we are going to see out of our box, out of our Hadoop. And also we are going to see the course content out of this training, what and all we are going to cover as a part of our Hadoop training in this training. And also we are going to discuss about the course duration to complete this course content. And also we are going to see at end how to learn this Hadoop framework easily and how to crack the job within the Hadoop market. That's what I'm going to discuss very thoroughly. Okay, let's go ahead and jump into our today's agenda. Let me go ahead and introduce about myself. I'm one of the corporate trainer from keeponlearn.com. Okay, I have total 10 plus years of IT experience. Out of that, I worked as a Java developer initially. From quite some time, I worked as a mainframes developer. From last 4 years, I am in data, big data analytics actually. My current role is Hadoop architecture, and I'm working as a, initially I started my career as a Hadoop developer, and I have done my certification in Cloudera, and it's the Hadoop architect. Okay, and out of my 10 years of IT experience, I was there for 5 years at my client location in United States of America. And so far, coming to my training experience, so far I've trained more than 3000 plus students in Hadoop alone from beginning of my IT career of my Hadoop. And I did work in the different domains. I did work in the telecom domain, I did work in the insurance and auto finance, banking, as well as the retail domain. So these are all about my experience in the different domain. Okay, apart from this one, so far in my training, I train the people, or I train the students who are just out of their graduation and they wanted to start their career in the IT profession. I was able to train them successfully. I was able to place them in the project. And also I train the IT professions who are already having so and so experience, probably 5 years, 10 years, 15 years of experience, and they wanted to switch their career to the big data Hadoop, or they wanted to add this Hadoop skill set to their resume. I was able to train those professionals also successfully. I was able to place them in the project within their organization. Okay, and that's all about me. Let's go ahead and discuss about what are the topics that we are going to cover here. So first and foremost thing, what is big data actually. So you might have heard from many people, we are going to give the training in big data and Hadoop and big data and Hadoop. So these are the things that we might have heard about from the different people from the different organization. But what is this big data? Okay, let me clarify one thing very clear here. Big data is not a framework actually. Okay, it's not a framework where we have to learn. Okay, it's not a language, it's not a technology. Okay, so what is this big data? Big data is really, it's a problem statement actually. Okay, right now we have some problem that is called big data. So what is that problem that we have? Big data is nothing but simple as a data. Okay, huge data that we are putting together, that is called big data. So as you know, earlier we used to measure the data in terms of bytes, kilobytes, megabytes, gigabytes, terabytes. We know that we used to measure the data all the way this in this one, and we know that we are able to handle this data using our existing computational techniques also. But from last decade or from last 5-6 years onwards, we are seeing the data in terms of petabytes of data, exabytes of data, zettabytes of data, and yottabytes of data also. So all the way till this point of time, we are okay to handle this data, this kind of data, whatever we have in our existing computational techniques. With them we are able to handle that one. But as you know, throughout this world, the internet enabled devices are generating a lot of data. That is the reason we are getting lot of data from different data sources. So existing systems are not able to handle this data. So what is big data issues now? Big data is having two issues. As you know, the data is coming from the different sources continuously. So that data we are not able to handle it using our existing computational techniques. So what are the big data related issues? The first one is going to be here is storage wise. Okay, we are getting the tons of data from different devices and we are not able to store the data on time. And the second thing is processing one. Somehow we are able to manage the data, how to store the data by adding the different hardwares and all to the system, or adding many servers to our system. We are able to manage somehow, but when it times when it when time comes to process the data, we are not able to do it on time. So currently, what is on the real world, what are the two issues that we have with our big data? One is storage wise, one is processing wise. Every day we are getting the terabytes of data from different data sources. Because of that, we are not able to store it and we are not able to process it on time. Okay, then okay, we are good. From last 15-20 years onwards, we are dealing with data, big data, probably terabytes of data. But what are the issues that we have with our existing computational techniques? Okay, so whenever I say existing computational techniques, it can be like Java, mainframes is the system which is a bigger system, where whenever you feel like you are going to deal with your big data, they used to start the technology, or they used to adopt the methodology called mainframe actually. Okay, or any data warehousing tools or any BI related tools, they are straining to process the data actually. They are straining to store the data and straining to process the data. Why? Because whenever they are developing these tools, whatever we see, Java, .NET, mainframes and all, they did not think like we are going to see this much of data. That is the reason they did not address these big data related issues in the time of they are developing this technologies, framework, or whatever it is, tools actually. So all the way till this point of time, even along with SQL also, not only with this one BA tools and or DBMS databases also. Okay, like DB2, MySQL, all those things, they are okay to deal all the way till terabytes of data. But when the petabytes of data is coming and getting added to your warehouse, we are not able to store it and we are not able to process it on time. Okay, that is why exactly why our existing systems are straining with that one. I'm going to put more on this one, why we are existing systems are straining to process the data. But as of now, existing systems are having two issues. One is the storage wise, one is the processing wise. They are able to store, they are able to process, but we are not they are not able to give the reports on time. They are not able to take the business decisions by analyzing the raw data on time. Okay, that is what exactly is going on with our existing systems actually. Then from where we are getting, what is about the storage, why we are all of a sudden started talking about storage, why all started talking about the processing, are we really getting the data? Okay, I'm going to show you the very clear picture from what and all data sources we are getting the data, and we are not able to store it, we are not able to process it. Before that, let me go ahead and define big data using some of the V's actually. This is going to be the IBM definition actually. It's very important thing. Definition of IBM definition of big data here. So generally we are going to define our big data using some of the V's. Okay, first one is the volume of data, the second one is the velocity of data, the third one is the variety of data, the fourth one is the veracity of data. So what I mean this one, so what I mean by volume of data, volume of data is nothing but the amount of data that we are adding from data source to warehouse is called volume of data. Example, probably 100 bytes, 100 megabytes, or 100 terabytes, or 1 petabytes also. Okay, this is going to be your, this is going to be the volume of data that you are trying to add to your from data sources to the warehouse actually. Okay, the volume of data, that is called volume of data. Then the velocity, at what speed, yeah, we are trying to add probably 100 megabyte, 100 gigabyte, 100 terabytes, or 1 petabyte of data from your data source to the warehouse, but at what speed we are trying to add, at what speed the data is getting added to the warehouse from different data sources actually. So probably I'm going to add 100 GB of data in a week probably, or in a day, or in a year. Okay, this is called, so at what speed we are trying to add so and so data from our data source to the warehouse is called velocity of data. Okay, the next thing here is variety of data. Okay, so as you know, the data that we are going to get with any data source, it's going to be fall under three categories. One among these things, one is going to be the structured one, so second one is the unstructured data, and the third one is the semi-structured data. Okay, so what I mean by structured data, whenever we are going to keep the data in rows and columns in an organized way, then that time we are going to call it as a structured data. We know that the unstructured data is very simple. It does not have any meaning to the data. As you see, whatever data that you got, if you are trying to read that one, you may not able to understand what is each one actually. Okay, you are not going to see from so and so position to so and so position, we are going to call it as a ABC column. We don't have any organized data here. So in order to make it unstructured data to structured data, we have to process this data. And the last one here is semi-structured data. So what I mean by semi-structured data, the best example, only half of the way only we organize the data, remaining half of the way it's a unstructured data. The best example here is XML files, okay, JSON files, and the clickstream data. Nowadays we are getting the data, clickstream data from different data sources also. So that is going to be your semi-structured data. So at what kind of data that we are getting from the different data sources to the warehouse, or what type of data that we are trying to add from different data sources to the warehouse is called variety of data. Okay, then the last one here is velocity of data. Velocity is something very unique for our data actually. For example, I got 10 terabytes of data from ABC data source and added to the warehouse actually. So in this case, out of 10 terabytes of data, how much data that I am going to utilize, or how much data that I am going to see as a valid data to do my further data analytics actually. I'm not going to process my entire 10 terabytes of data, or I'm not going to use my entire 10 terabytes of data to do my ABC data analytics. Out of 10 terabytes of data, I might needed only 1 terabyte of data for further data analytics. So in this case, to extract 1 terabyte of data out of your 10 terabytes of data is not an easy task. So remaining 9 terabytes of data is valid data also, but we have to, for other purpose, that 9 terabytes of data is valid. So we cannot go ahead and just only collect 1 terabyte of data. Remaining 9 terabytes of data, we are going to purge it. We are not going to purge it, we are not going to delete it. So that 9 terabytes of data for other data analytic purpose, I am going to use it probably. So that is called veracity of data. Extracting the valid data or useful data out of your whole data is called veracity. So let me go ahead and put all this together to define my big data. Whenever, if you take any data set, big data set or any data set who is having high in volume of data, high in velocity, high in variety, high in veracity. If the data set is having these 4 characteristics, then that time we are calling that one as a big data. This is very important thing, the big data definition using 4 V's from IBM side. Okay, so yeah, are we getting really this much of data? Really, are we getting this high volume of data, high velocity of data? Means in a day, are we going to add this much of data from different data sources to the warehouse? Are we getting different format of data? Are we getting like this much out of data? Are we really required to process and pull only the useful data out of this one? Are we really getting this much of data from different data sources? So for that, I just got one simple PPT where I've shown very clearly here from different data sources. You can see right now we are living in a data world. Actually, if you take any social media, if you take any insurance domain, if you take any healthcare domain, if you take any telecom domain, we are getting the data from different sources, like huge actually. So you can see this picture is really shows very clearly how much data that we are getting from the different data sources. You can see YouTube within 60 seconds of time, which means within 1 minute of time, how many new videos are getting added to the YouTube warehouse. Actually, how many? 600 plus new videos. So how many new domains are getting registered? 70 plus new domains are getting registered within 60 seconds of time. Actually, how many emails are being sent, how many new searches are happening only out of Google? You can see around almost 700,000 searches are happening within a 1 minute of time. How many new images are getting added to the Flickr site, and how many Skype calls are happening? You can see these all are like, it's going to talk about, the first one is volume of data, the second one is velocity of data, the third one is variety of data, which means the different types of data that I'm trying to add. So whenever you say audio files, video files, image files, they are all like your unstructured data. So we are trying to add different format of data from our all different variety of data sources to our warehouse. And also the last one is going to be the veracity of data. Yes, we are trying to add this much of data from our different data sources, but are we going to really use this entire data for our further data analytic purpose, or further to take any business decisions, or to address the customer complaints? Probably you are going to use only portion of the data. So to extract that portion of data only, we are going to call that one as a veracity of data. Okay, so this one clearly shows that whenever you are generating this much of data, as you know, how you are going to add, you are going to take one machine, one server, and you're going to keep on adding to that one. Once that is full, probably once it is become around 10 terabytes of data, which is a super duper computer, after that we have to replace this machine, or we have to route your data to the different machine again. So as you know, we are keep on adding the data, keep on adding the different servers to our, to retain our data. So as you know, how many machines that you can add here? Probably limited machines only. After that your system will not be scalable. It's not going to be the scalable. Why it is not be scalable? As you know, probably by the time you reach probably the 15 server or 16 server, probably this data is going to be the 5 years of data. But whenever my data analytics says that I would like to just perform the data analytics on top of my 5 years of data, We have to again keep your entire data together, then we have to process the data. We cannot go ahead and process this data individually. We don't have any mechanism as such. So storage wise, somehow we are able to manage by storing the data into the different computers, but when it comes to process the data, we are not able to do that on time, because this terabytes of data, this much terabyte of data, and all servers terabytes of data, if you're trying to keep together, we are failing to do that one. That is what exactly we have issue with our big data. We are not able to give the business decisions, or we are not able to address the customer complaints, or we are not able to take any business decision based on this raw data on time. That is what exactly is happening with our big data currently with our existing technologies. So whenever I say existing, it can be Java, .NET, mainframes, or any data warehouse related tools, or it can be BI related tools also, or it can be RDBMS related database also. Okay, that is what exactly it's going on with our this thing. Then how we are going to address this issue? Okay, so this, to address this issue only, Hadoop and Hadoop kind of technologies came into the picture actually. So that's what I'm going to define what is Hadoop. So big data and Hadoop. Big data is a problem statement. You're very clear about this one. Hadoop is a Hadoop is a techniques where we are going to address that problem statement actually. We have Hadoop kind of technology. We have Spark, we have Flink, we have some other Cassandra, MongoDB. There are many different frameworks are there where we can address this big data related issues actually. One among them is Hadoop. Hadoop was born to address the big data related issues only. So what and all issues? Let's go ahead and define what is Hadoop. There are many definitions for Hadoop. Let me go ahead and define what is Hadoop actually. Hadoop is a open source framework. Okay, so I'm talking about two words here: open source framework. Whenever you say open source, it is free to use. It's a freeware. You don't have to pay any money if you want to use this software, and it's a framework. So what I mean by framework here, whenever you say any language or anything is a framework, which means almost 60 to 70% of work is done by the framework. Only the developer or admin has to do what, remaining 30% only he has to take care of that one. That is called framework. Okay, Hadoop is a open source framework which is written in Java, completely in Java. So it does not mean that you have to know Java in order to start learning the Hadoop. Written in Java on Linux platform, which is going to address two issues. It's going to address two issues from big data side. One is going to be the storage wise, and other one is the processing wise. So these are the two issues. Hadoop was born to address these two issues from the big data side. Hadoop is a open source framework which is written in Java on Linux platform, which is intended to address the two issues out of the big data. One is going to be the storage wise, other one is going to be the processing wise, using distributed concept actually. So what I mean by this distributed concepts, that's what I'm going to discuss very thoroughly. Using distributed concepts only, our Hadoop framework is going to work out. Let me go ahead and introduce how Hadoop architecture, which means what is this distributed concepts, how my Hadoop framework is going to work. Then we are going to discuss why only we need to have Hadoop when we have Hadoop kind of technologies in the market. Exactly, that's what we are going to discuss very thoroughly now. So let me take you back to the PPT. Like I said, I'm going to use very limited slides here. So this is going to be my next slide. That's all we are going to use in our entire this thing. I don't want to bore you too much. Okay, so now let me just take you to the next slide here. So generally, whenever you are getting the data from your data sources, probably you can take any data source. Okay, whenever you are trying to add the data warehouse that you are going to probably choose is your database. Probably any database that you want to consider. Let's go ahead and take this is my database. I'm trying to add some data from data source called the data source, probably whatever data source, the data source is going to be the Amazon, and I'm trying to get some data. I'm trying to add the data to the data source called MySQL. So as you know, how much data that I'm getting from my data source, 10 terabytes of data that I got. So obviously using only one machine I need to store the data. Okay, I cannot divide this one and store somewhere else. What I'm going to do, I'm going to route my entire 10 terabytes of data to the single server. So that's how I stored my data. Okay, so obviously whenever it times to process the data, whenever I wanted to process this 10 terabytes of data, obviously I need to write some programming techniques actually. So whatever programming, probably this is a transaction data. I would like to find out probably how many products I've sold today, which product I've sold how many times, which one I sold, which one I sold maximum number of times. That is the statistic, that is the dashboard that I need to come up out of my data actually. So obviously I need to write some program here. Okay, I can use Java, I can use .NET, I can use any technology where to find out this business requirement out of my data actually. So I've written the program here, and I'm going to just I'm going to write the program to work on top of this data. Obviously, which how many machines that are going to work on top of this one? Only one machine only has to work on top of this data, because there is no other machine. We cannot process this off of the machine in one way, off of the machine other way. Only single machine has to process this entire 10 terabytes of data. That's what it's going to work out. Then whereas if I'm going to have the same problem statement using my Hadoop, how I am going to address this one? First of all, let me make it very clear. Hadoop is going to work based on master slave architecture. So what I mean by master slave architecture, we are going to have one master computer. That computer is going to take care of my some other computers where I have under that machine. Can you see here very clearly? Here I have one master machine, and under that I have added few more machines together, so that here this machine is the one who is going to take care of all me this my slave machines actually, slave computers. This is my master computer, these are my all slave computers. Here you can see my 10 computers are going to be the slave computers for my master computer. So now what I'm going to do, I'm going to just put them together, where this all my 10 machines are handled or managed by who? Master. Master is nothing but is a manager who is going to manage my entire system here actually. So this is going to be the entire system actually. So within the network topology, whenever you are going to have more than one machine together within the network where they can talk each other, that time we are going to call it as a cluster actually. So what I mean by cluster, you can see this is the cluster. So it's rounded up, whatever you're seeing, that is a cluster, which means I have more than one machine together within the network where they can talk each other. This machine can talk to this one, this machine can talk to this one, this machine can talk to this one. So this all machines can talk each other. That is the reason we are calling this one as a cluster. This cluster is not unique for our Hadoop. It was already there in the network. So whenever you are putting this machines are put in the master slave architecture type. That is the reason we are calling this one as a Hadoop cluster. My Hadoop cluster is going to follow the master slave architecture within my cluster actually. So one machine is going to manage all my remaining machines actually. Whereas you can have the cluster also where you don't have to be in this order. You can have 3-4 machines together, and you don't have to like put it in the master slave architecture, but still we are going to call that one as a cluster only. But in this case, again I'm repeating what I mean by Hadoop cluster. This is called Hadoop cluster. What I mean by Hadoop cluster here is I'm going to put more than one machine together where they can talk each other in a master slave architecture. That is called Hadoop cluster actually. So let's go ahead and see how we are going to address this issue. Whatever we have seen actually, whenever you are going to process the 10 terabytes of data, okay, using single machine, obviously you are going to take lot of time to find out your end results. Whenever you fire the query on top of that, it is going to take long time to process that one. Whereas I would like to process the same 10 terabytes of data using my Hadoop methodology. How my Hadoop methodology is going to address, that's what we are going to see in our next slide here. You can see here exactly, as we know, this is a big data. For us, this is the big data. So whenever we are going to discuss how to address the storage wise issue using our Hadoop methodology. That's what I'm going to discuss. So as you know, this is my entire 10 terabytes of data. Again, I got my from data source called amazon.com. Then I'm going to just got the data into my Hadoop cluster. Then what I'm going to do this one here is, instead of storing this entire data together, my Hadoop cluster, which means my master machine, is the one who is going to let my client to divide this data into chunks of data. Can you see now here, instead of storing my entire data into one machine, what I'm doing, my master computer is the one who is going to be in touch with some of the configuration files, and it's going to come up with the mechanism saying that instead of storing my entire 10 terabytes of data into single machine, I'm going to divide into small slice, so that each slice is going to be the not big data. Here this was the big data, but here it's a normal data. So now what I'm going to do, instead of just storing the entire data into the one computer, I'm going to divide into 10 pieces, and that request will go to the master computer. Master computer is the one who is going to be allocating each slice as to go into what machine. That is what my master computer is the one who is going to coordinate with my client. Then each slice will be put into the different slave computer. Actually, can you see here, I put one terabyte of data in this one first machine, and the 1 terabyte of data in the second machine, and 1 terabyte of data in the third machine. So as you know here, whatever we just divided the data into multiple computers and distributed into more than one computer. Okay, so whatever issue that we have seen here, we are able to address the storage wise issue. Whatever we have seen here, we are able to address using our Hadoop methodology. Instead of storing in a single machine, we have distributed to the multiple computers. Whenever in future, whenever it is a time to process this slice of data, instead of, again, I'm not going to keep the data together, which we are going to discuss in our next slide here. So this one, whatever you are seeing here, the way we distributed the data, okay, the way we divided the data and distributed the data into multiple computers, that concept we are going to call it as a HDFS, Hadoop Distributed File System. That is called HDFS. Okay, what I mean by HDFS? HDFS is a Hadoop Distributed File System. The way we have addressed the big data related issues in terms of storage wise. So using the HDFS concept only, the core concept only of our Hadoop, we are going to address the storage wise issue that we have out of our big data. Okay, we are able to divide the data and distribute the data into multiple computers, but how about when it's time to process the data? Okay, as you know, it is not only the storage wise issue that we have out of our big data. We have processing wise also issue. As you know here, after you store the data into this one, it is taking long time to process the data. It's not going to see the results on time. But whereas here, let's go ahead and see how my program is going to work in a distributed manner. So exactly what I'm going to do, obviously whatever the problem statement that I have, whatever the business requirement that I have, I need to put it into the program. So I need to write the program here. So what I'm going to do, I'm going to write the program here, and now the program, whatever program that I've written, I'm going to hand over that one, the same thing, to the my master computer. Master computer is the one who is going to pass on the same program to the individual machines. Instead of pulling the data all together and processing the data, what I'm going to do, the same program will be sent to this machine, will be sent to this machine, will be sent to this machine, and this machine, all the way this machine you can go ahead and send the data. So that is what exactly is going to happen. And before I take on, probably if I want the more storage capacity here to address the storage wise issue, as you know here, we have to route the data to the different machines. So whereas whenever I wanted to just store the more storage capacity, simply I'm going to add the one more computer to my cluster. Actually, that is possible actually. Okay, so that is how we can address the storage wise. Let's move on with the processing wise. So as you know, the program, the same kind of program that we are going to write it, and we are going to send it to the client, is the one who is going to send it to the master computer. Master computer is the one who is going to send the same kind of logic to the each computer wherever I have stored the data. wherever each slice is there, that slice the data, the program will be sent and that will be processed there only. So the technique whatever we used, how the program has sent to the nodes or sent to the computers where my data resides. So here one thing that you have to observe very clearly, whenever it's time to process the data, whereas if you have seen in our earlier thing, we are not going to keep the data all all together to process the data. The data is going to be processed how you have divided the data into multiple computers. You can see here 1 terabyte of data, on top of 1 terabyte of data that program is going to work, and 1 terabyte of data that program is going to work. This is the different techniques or paradigm that we are going to use out of our Hadoop methodology. So we are not going to pull all your entire data together to process that entire data in a single computer. So whatever we just used, instead of pulling the data all together and processing your data again in a single machine, my Hadoop methodology as a paradigm where it is going to send the program to the individual machines, the broken down whatever the individual, however how we divided our file into chunks of data, on each chunk we can go ahead and process the data. The way we are doing that one is going to be called Mapreduce. Okay, that's what it is exactly the way we are going to process the distributed data in our Hadoop program. Hadoop methodology is called Mapreduce. So what I mean by Mapreduce, Mapreduce is a programming method, it's a paradigm using which I can process the divided data. The whole data is divided into chunks of data. I can go ahead and process the chunk of data individually, independently, instead of placing them all together. That process is called Mapreduce. Mapreduce is going to work based on what help? Based on my Hdfs help only it's going to work. Okay, so as you know, the data is distributed. So as you know clearly, instead of processing the 10 terabytes of data out of single machine, we are going to process the individual machine. Instead of working one machine, you can see here 11 machines are working on top of your 10 terabytes of data. That is what exactly called parallel processing. Instead of single machine is working on top of your data, we are seeing here parallelism. We are seeing 11 machines are working on top of your data. That is the reason we are going to see the data analytics on time. We are going to address the customer complaint very easily on top of your big data. So if you want more storage capacity, just go ahead and add one machine to your Hadoop cluster, one slave machine to the Hadoop cluster. If you want more processing capacity, just go ahead and add one more machine to the Hadoop cluster. That's how we are going to increase our cluster capacity. This is what exactly the difference between, you can see the right side how the legacy system is going to follow, and this is the left side, you can see the Hadoop methodology how it is going to follow to address our big data related issues. Okay, so let me take you back here. So here we have seen two issues. What and all we are going to learn? Hadoop is going to follow the master slave architecture. Master slave architecture, and master slave architecture is the one, master is the one who is going to take care of my entire cluster, and slave machines are the one who is going to work for my master machine for to address my storage wise issue, to address my processing wise issue. Okay, so that is all about how our Hadoop framework is going to work. We are going to see a lot as we go on with our classes. I'm going to teach you more about the master computers, more about the slave computers, how the data will be divided, and how we are going to add this thing. Okay, and one more thing before I move on, features of our Hadoop. Let me go ahead and tell you one thing here. Probably you might be thinking here, instead of just using or having one machine here, I've used the 11 machines. So obviously instead of buying one machine here, I might be taking the 11 machines here. That is the obvious question that will be getting in your mind. So there is a more expensive for the organization. But here my Hadoop features, one of the Hadoop feature that we are going to have here is, here whenever you are going with this legacy systems or probably existing computational techniques, this server should be always up and running. If this server is going down, the data that was there in this one will be inaccessible. That is the reason we have to use always the enterprise hardware. What I mean by enterprise hardware are the high reliable hardware, okay, they will not go down very frequently. Okay, so as you know, whenever you wanted to have the high reliable hardware, you have to spend a lot of money. Okay, so whereas the left side you can see here, my Hadoop framework says that it can go ahead and store the data, it can go ahead and process the data using the commodity hardwares. Okay, commodity hardwares are the cheap hardwares, low reliable hardwares. Okay, commodity hardware are the cheap hardwares, low reliable hardware, they may go down anytime. They are the general purpose hardwares. Whatever we are using in our machines, they are the commodity hardwares. They may go down very cheap hardwares. So what are the difference between these commodity hardwares and cheap hardwares in terms of price here? So probably if you want to buy 1 terabytes of hard drive, okay, in our commodity hardwares, as you know, how much you have to spend? Probably 50 bucks. Whereas if you are going with the enterprise hardwares, in order to buy 1 terabyte of hard drive space here, you have to spend 5k, $5,000, because this is a very high reliable hardware. That is what you have to use for our legacy systems in order to make sure they are up and running in our production environment. If you are using the commodity hardware, cheap hardware, they will go down at any given point of time. We may not able to come up with our solution. So that is the reason we have to use enterprise hardware, but our Hadoop methodology claims that it can go ahead and use the commodity hardware, so the cheap hardware. Then how about, then if it is going down, one of the machine is going down, then how we are going to recover the data? If this machine is going down, and how I'm going to recover the data? Because my Hadoop framework, the nature itself, it says is a commodity hardware. The hardware nature itself is a commodity hardware, it is a cheap hardware that it may go down anytime. Then how we are going to recover the data? Okay, using our beautiful concept called fault tolerant, using beautiful concept called replication factor, we are going to make sure our data availability is a lot in our Hadoop cluster. We are going to see increased data availability using our replication factor. I don't want to take you that there, because we are going to cover very thoroughly in our classes. Okay, using our replication factor, the fault tolerant can be addressed. What I mean by fault, this is a fault, right? We are using the commodity hardware, it may go down anytime, very low reliable hardware, cheap hardware. So how we are going to tolerate that fault? That is what we are going to see with using our replication factor. So that is what we are going to discuss in our Hadoop features. What and all Hadoop features? Why we have to go with Hadoop when you have Hadoop kind of technologies in the market? So like I said, Hadoop was born to address the big data related issues only. So the first and foremost thing here is Hadoop is going to be the scalable language. So what I mean by scalable language here, scalable framework or language. What I mean by scalable here, the more machines that you want, you can go ahead and add. The more machines that you want, you can go ahead and add. The more storage capacity, just go ahead and add one machine. The more processing capacity, you can just go ahead and add one more machine to the system. That is called scalability. There is no limit to add the number of machines to your cluster as well. Actually, you can add how many computers that you want, you can go ahead and add to your cluster. That is called scalability. We have some other frameworks, technologies in the market where it is a scalable language. So here one of them is our Hadoop. Hadoop is going to follow the master slave architecture, and also it's going to store in a commodity hardware. Okay, as you know, commodity hardwares are the cheap hardwares. Okay, so the best feature means you don't have to spend a lot of money. Whenever your organization is trying to adopt any methodology or any framework or any technology, what they are going to do first and foremost thing, how much money do I need to spend in order to maintain this one? So if you are going with Hadoop, you don't have to pay any money for the software, as well as we don't have to buy very high reliable machines. You can go ahead and buy the normal machines, whatever we are using generally in our day-to-day activities. We can just go ahead and use them for our even our prod environment I'm talking about. Okay, so that is called scalability. Okay, that is called commodity hardwares, and you can store the data in a whatever data that you are getting from your different sources. You can go ahead and store the data in Hadoop framework directly. Okay, you can just collect the data from different data sources and store the data there. You don't have to say that okay, you have to process and then only I can I can accept the some format of data here, then only I can process the data. No, our Hadoop framework is going to collect the data from different data source. It can be satellite data, it can be sensor data, it can be trucks data, it can be um, um, servers data. Whatever you take, it can easily collect the data and put it into the database. And also it is going to be one more thing here is fault tolerant. Okay, fault tolerant is nothing but, as we discussed here, there is a fault, we are going to address them whenever your one of the machine is going down. Okay, one of the machine is going down here, it is going to recover automatically. It's going to recover automatically the data, whatever it is there here, the data can be recovered somewhere else, here or here, after certain given period of time. That is going to be the fault tolerant using your replication factor as well as this heartbeat, which we are going to see very thoroughly as we go on with our classes. So these features are available. There are many features. These are the main features that we are going to see out of Hadoop. That is the reason we have to go and use the Hadoop when you have a Hadoop kind of technologies in the market. Okay, so then let me take you to the next topic. That's going to be what and all topics, or what is the course content that we are going to cover throughout our training. That's what we are going to discuss very thoroughly. So as you know, we are going to discuss HDFS, okay, Hadoop distributed file system. Okay, the storage wise issue, whatever we have, the storage wise issue is addressed using this core system, ecosystem, core system, you can call it as anything. Okay, eco component, core system, ecosystem. So we are going to discuss very thoroughly about HDFS, and also we are going to discuss about the Mapreduce. Mapreduce is the paradigm. So one thing that you have to understand, Mapreduce is not a programming language. Okay, it's a paradigm. It's a technique where you can process the divided data, or however you divided your data and stored into the multiple computers, it can go ahead and process the data that way. So in this case, as you know, this is the Mapreduce is the programming techniques actually. So obviously, in order to write your Mapreduce program, we have to have some language, okay, like Java, okay, C++, okay, or probably Python or Ruby on Rails, okay, etc. So we have to have some basic knowledge one among these technology in order to come up with our Mapreduce program. Without that, there is no way we can come up with the Mapreduce program execution. So in this case, so basically Hadoop is written in Java. That is the reason 99% people are going to use the Java only. Like means Java means core Java, very basic core Java required here. Okay, so as we know, people who are there in the market are very less. Okay, then how we are going to write our Mapreduce program? People who are having this Java, C++, Python knowledge are very less in the market. Then how we are going to learn? Or people who have used this Hadoop methodology, they started struggling with this skill set actually. People who knows Java, who knows C++ in the market is very less. So that is the reason, to maintain the Mapreduce programs itself, they got a lot of struggle. They are struggling a lot with the to maintain the Mapreduce programs. Then if no Java, or whatever the programming techniques, then how are we going to really code our Mapreduce program? Are we really going to do our data analytics using our Hadoop framework? The answer is yes. Probably if you are knowing basic SQL knowledge, as you know, if SQL knowledge will be there in our college days also, in academics also we are going to see that one. So as you know, if you have a E0 level knowledge in the SQL, then you can go ahead and start working with Hive actually. Hive is same as SQL. Okay, so it's a Hive query language, same as your structured query language. So it's going to work exactly the same way. So whatever queries that you have written, the queries, the Hive queries, Hive queries, we are going to write our Hive queries in the E0 queries, very select, insert, update, joins and all, very simple queries. Whatever the queries written Okay, those will be converted into series of Mapreduce program. Okay, series of Mapreduce program using what? Using Hive framework. Okay, so here end of the day my big data will be analyzed using the Mapreduce program only, but as a Hive developer I am not going to write any Java program. I am not going to write any Mapreduce program in order to work on my top of the data. I am going to simple write the 2 to 3 lines of Hive queries. That will be, those queries will be converted into the series of Mapreduce program by my framework. I don't have to explicitly go ahead and write anything to convert them also. All I'm going to write the queries. Those queries will be converted into series of Mapreduce program. Okay, that is what the, if you don't want to know anything about Java, if you don't want to learn anything about Java, then go ahead and start your Hadoop career as a Hive developer. But if you think like, no, I don't know about SQL also, then we have one more option, that is called Pig. Pig is the one, Pig is going to use scripting language. Don't think like scripting language is a scripting scripting language is like Java scripting or VB scripting or all. It's very simple language. It's going to follow the Latin scripting language. It has its own scripting language. It's called Latin scripting language. Okay, using which, again, this is very easy to learn, within 2 to 3 hours you can learn, very easy to learn. Within 2 to 3 hours you can go ahead and learn this Pig scripting. This is very easy. After you learn that, you can go ahead and code in your, on top of your data, whatever big data that you have, that this transformations, whatever the Pig transformations or Pig scripts will be converted. These Pig scripts will be converted into series of MR using Pig framework. Exactly, this is what it is going to work the same way. The Pig and Hive both are going to work in the same way. Your Hive is developed by Facebook and the Pig is developed by Yahoo. The intention of having these two products are just in order to, whatever the complexity that we have writing our Mapreduce program, in order to ease the writing the Mapreduce complexity of Mapreduce program, we are going to just come up with the Hive or Pig. They're very easy, but in the background this Pig script Hive queries will be converted into series of Mapreduce program, and they're going to work on top of my Hdfs file system, which is my storage one. Okay, so you can go ahead and portrait yourself as a Hive developer. If you don't want to learn Java, you can portrait yourself as a Pig developer. You don't want to learn Hive also, you don't want to learn SQL or Mapreduce. So these are the three different ecosystems using which we can process our data that you are stored in our Hdfs file system. Okay, on top of this one, we are going to cover very thoroughly about HBase. HBase is a columnar database. Okay, columnar DB or column oriented DB, we can say column oriented. So what I mean by column oriented, so as you know, if you are taking RDBMS, we are going to have the rows and columns here. Row oriented database, as you know, MySQL is a row oriented database. On your Hive also is a row oriented database where we'll be having the rows and columns. But whereas your HBase, what is the difference between this one here is, we are going to see very thoroughly what is this columnar database, and also we are going to call this one as a NoSQL database, not only SQL database. Using this one, the power of your NoSQL database here is, we can store the billions of records in DB. So as you know, whenever you are going to store the billions of records in our MySQL or any RDBMS databases, your system will strain actually. If you are running the query against that data, we are going to see after 2 to 3 days only we are going to see our query results. Okay, that is the results out of your, when you are going to have the billions of records on your RDBMS database. But using your HBase, you can just store the billions of records in the DB and we can go ahead and get just like that. You don't have to put much efforts to get out of your HBase. That is what the power of our HBase. Actually, we are going to see very thoroughly about HBase, which is the base for your NoSQL database. We are going to see very thoroughly, and after that we are going to discuss Scoop. So what I mean by Scoop, so before I introduce the Scoop, as you know, probably if you take any organization or if you take Facebook or Amazon, they might be using MySQL as a database earlier, probably to store their data, structure or semi-structure or unstructured. To process their data, they used to use the MySQL. But as you know, the MySQL is just having lot many issues. It's not able to uh, process the data, it's not able to store the data on time. That is the reason we are slowly moving to the Hadoop. Then whatever data that we have in our MySQL, in order to just dump the data into our Hadoop side, it can go ahead and keep the data into your HDFS, or you can go ahead and put the data in the HBase. You can go ahead and keep the data into Hive also. In order to dump the data, in order to import the data, okay, in order to import the data from MySQL into or RDBMS related databases into the HDFS file system or Hadoop framework, we are going to use the methodology called Scoop. Okay, it is a ETL tool from our Hadoop side, using which you can import the data from RDBMS databases into Hadoop. Okay, and also you can export the data back from Hadoop to RDBMS databases also. Okay, this is the tool using which you can use import and export the data back and forth. Okay, so that is the reason we are going to call this one as a, whenever you say Scoop, okay, Scoop means SQL to Hadoop. Okay, so that is what the purpose of having the Scoop. So we are going to discuss very thoroughly about Scoop also in our training. And also the next ecosystem that we are going to discuss here is Flume. Flume is going to be also the ETL tool, using which you are going to collect the streaming data. So what I mean by streaming data, I'm going to collect the streaming data from different data sources. So what I mean by streaming data here, whenever you say the data is streaming data, means continuously a data source is generating the data. The best example for this one is if you take any server log. So as you know, people who are trying to access your server, always there will be the access log, network log, error log. Those logs will be getting generated and added the data towards those logs actually. That is called your streaming data. And one more example for this one is, as you know, if you are taking any plane that is flying from India to United States or some different place, as you know, as it is flying through, it's going to generate a lot of data. So you have to collect the data then and there. So using Flume, you can go ahead and collect the data and put it there into your HDFS file system. Collect the data from different sources and import into Hadoop. We can do that one using Flume very thoroughly. Okay, and also we are going to discuss very thoroughly about next ecosystem is called Oozie. Oozie is a scheduler actually. So what I mean by scheduler here, so as you know, in order to come up with our data analytics here, in order to do ABC data analytics on top of your data from your organization, you cannot just go ahead and rely only on Mapreduce. You cannot just go ahead and rely only Hive. So you have to run n number of jobs or more than 2 to 3 jobs in order to come up with your final report. So as you know, you have to run those jobs in a particular order, in a desired pattern. Okay, in order to run the jobs in a desired pattern, we are going to schedule. It's a scheduler. We are going to schedule the jobs. So you can go ahead and do it manually, and using Oozie we are going to schedule them. It's very small tool and very powerful. Oozie is the one who is going to be working as a scheduler, and we are going to schedule the jobs as per our requirement. Okay, so on top of this one, okay, in our training, okay, we are going to see the software also. Okay, I'm going to give it you we are going to give it as a software for free, where you can access 24/7 for lifetime. Okay, and also we are going to give it, I mean the requirement for your software, if you want me to talk about the requirement for your machine requirement for this one is 4 GB RAM, and hard drive can be anything. 4 GB RAM is enough and hard drive can be anything. This is hard drive can be even though 500 GB or 200 GB also it's enough. 30-40 GB is enough for you. Okay, so now 500 GB enough is enough to start working with Apache Hadoop. Okay, and along with this one we are going to see very thoroughly about the use cases for each and every ecosystem that we have discussed from the beginning. We are going to see the use cases. What I mean by use cases here, I'm going to give you the exercises and you have to work on top of that one. You have to come up with the real solution. So these use cases are going to be the real-time use cases. Okay, if you are working and able to complete them, you are going to get the feel like you worked in the real-time project. And also throughout my explanation, I'm going to give the real-time examples that I will try to extract. Using those example only I will try to extract the concepts out of that one. Okay, and also we are going to give the project guidance also out of this training also. Okay, these are the as a package that you are going to get all these things out of our this thing. On top of this one we are going to cover very thoroughly. Okay, we are going to cover very thoroughly about admin related course also. Okay, so this is what exactly this will come and sit here, whatever we discussed so far here, the topics that we discussed here. So this is what will go under this one. Okay, these are the topics that we covered, and the next thing is the course content. Before that, let me go ahead and add and what and all admin related topics that we are going to cover. As you know, we are not just going to cover only, I mean our training is mainly for our Hadoop development, but as our course is going to cover 25 to 30% of our admin related course also. So we are going to cover installation of single node cluster. Okay, we are going to see very thoroughly using single machine. It means whatever we have seen, this is only for the development purpose. I am going to show you very thoroughly how to do the single node cluster and installation of multi-node cluster. So what I mean by multi-node, more than one machine will be involved here, and we are going to make it as a cluster. Whatever you have seen in our diagram, in our explanation, I'm going to put it more than one cluster, one machine together. I'm going to make it like multi-node cluster, and you're going to see your data will be divided and distributed into the multiple computers. And also I'm going to teach you the installation of all ecosystems. Okay, like Big, Hive, HBase, Flume, etc. Okay, we are going to see very thoroughly the installation of all these things, and also we are going to see important configuration related things also we are going to see in our training. Whatever the important configuration things, how this division is going to happen, and how we can control the processing wise, how we can control the dividing your file into number of blocks, we are going to see very thoroughly by going into important configuration files. We are going to look into that, and we are going to make sure it is working as per our guidance. Okay, we are going to see very thoroughly. These are the courses that we are going to cover out of our admin related topics, and also on top of this one we are going to cover the advanced data analytics parts. What I mean by advanced data analytics part here is Spark. As you know, Spark is going to work based on the RAM. Spark is going to use RAM very aggressively actually. So we are going to discuss very thoroughly about Spark. Okay, and also the Spark streaming, Spark core, Spark streaming. Okay, and also as you know, in order to Spark is itself is not a programming language. Like how we had the map, in order to come up with the Mapreduce program we have to code in Java or C++. The same way here, in order to come up with your Spark application we have to have some APIs. So we are going to look into very thoroughly. One among them is Scala. Scala is a functional programming language, okay, using which you can develop the Spark application. So I'm going to teach you very thoroughly what and all skill set required to start with our Scala. I'm going to start with the Scala very thoroughly, and also we are going to discuss installation of Spark, okay, and different Spark cluster managers we are going to see, okay, like Spark standalone, okay, Spark on Yarn, Spark on Mesos, etc. We are going to see, and Spark local also we are going to see. That is what we are going to see very thoroughly, and installation of Scala also we are going to see, and integration of Spark and Hadoop. We are going to see very thoroughly with these concepts also very thoroughly as a advanced data analytics as a part of our training also. On top of this one, we are going to cover some of the BI related tools also. We have many BI tools in the market where BI tools will be used to visualize your data. Instead of just seeing the rows and columns, you can go ahead and create the bar chart, horizontal graph, pie chart and line chart, or histogram and field maps, and based on your data you can go ahead and create all these kind of maps. We can visualize the data easily. So we have many tools available in the market. So one among them is a Tableau is the business intelligent tool. We are going to see very thoroughly the installation of Tableau, okay, and also connecting, how to connect to the, we are going to see core concepts about your Tableau, connecting to the different data sources, okay. I'm going to teach you very thoroughly this one, okay, and also creating the sheets, dashboards and stories, and how working on Hadoop calculations and real time calculations also we are going to see very thoroughly, and also the integration between Hadoop and Tableau also. I'm going to connect through Tableau to Hadoop framework, and we are going to plot the graph based on that one also. We are going to see very thoroughly, and on top of this one, and on top of this BI tools also, you're going to get as a add-on, we are going to get support on. So throughout my training that I'm giving here, you're going to get the support, resume preparation. We're going to cover all these things in our training actually, okay, resume preparation, and also we are going to cover the interview tips and guidance and tricky questions. Okay, we'll be having some tricky questions, right? So I'm going to cover all of them in our throughout our training, and on top of that, at end of this our training, I'm going to cover again from the beginning at what level you got our out of our training, and what and all tricky questions that we are going to have in our out of training we are going to cover very thoroughly. And also the training, the material, the way we are going to explain is going to cover completely for our certification also. But if you need in offline the certification help also, I'm going to help you out on that one also. And also we are going to give you the material, okay, on Hadoop. It's kind of soft copies. We are going to provide the soft copies, okay, we are going to provide the soft copies. And also the most important thing here is, for at any given point of time, if you are busy, if you are not able to attend, okay, or if you feel like you wanted to go through one more time that we covered in previous days, so you can go ahead and just replay the recorded videos, okay. We are going to record all days record trainings that we are going to happen on top of this Hadoop, and we are going to share it to you, and you can use how many days that you want. You can go ahead and use that one, okay. That is all about the extra support that you are going to get on top of this Hadoop learning actually. So the course duration is going to be it's going to take around 45 to 50 hours max, okay, including 50 hours of time, including our resume preparation, the interview tips, and also whatever guidance that you need. And the training is going to happen in basically in 2 slots on weekdays, Monday to Friday, okay, and weekends, okay, morning and evening, okay. It's going to be the Saturday and Sundays, okay. These are the two different slots they are available, okay. We are going to see that one. And how to learn, that is the basic thing actually. Yeah, we are teaching well and all. The training that we are going to provide here is going to be the it's going to make you to just feel like you are working in a real time. Definitely you are going to see that feeling out of our training that we are going to provide here, okay. And the way we are going to meet every day, as you know, every day we are going to meet. I mean, if you are you are going with the weekdays, we are going to meet around 1 hour 10 minutes to 1 hour 15 minutes every day, around 75 minutes we are going to meet, okay. So after we met 75 minutes, if you are going to put extra 2 more hours, okay, 2 more hours, extra hours, if you are going to keep on top of this one, definitely you are going to crack the job what you wanted in your Hadoop actually, okay. So again, I'm repeating, every day we are going to meet 75 minutes. On top of that, you are going to put 2 more extra efforts that whatever we discussed today. So try to work on them, try to resolve the use cases, try to go through my classes whatever we discussed, and then go through the material that we are going to provide, and definitely you are going to crack the job in our Hadoop actually, okay. And if you have any questions, further questions, anything on this training, or if you need any help on top of this one, or for more training related questions, please use the comment box below, or you can just contact at keeponlearn.com. Okay. Thank you again for watching this video. See you soon. Bye. Hi all, thanks for watching this video. Welcome to introduction on Hive. So in this video we are going to see very thoroughly what is Hive, what was the purpose of having the Hive in our big data world, and where it's going to fit, okay. When you have our Hdfs and Mapreduce, why Hive was introduced, and what and all advantages that you are going to see when you are going to have your Hive in as a your processing component in your organization. And at the end we are going to see as the architecture how it is going to work out. We are going to see very thoroughly. Let me go ahead and introduce what is Hive actually. Hive is a data warehousing, or it's a tool on top of the which is built on top of the Hadoop, which can be used as a data summarization for easy data analytical queries, and also for the reporting purpose. This is the definition, so you don't have to worry about this one if you did not get anything out of this one. Let's go ahead and discuss where Hive is going to lie in our Hadoop ecosystems. Then I'm going to just come back to this definition actually. So as you know here, very simple thing here. Let me go ahead and just draw the simple diagram here. So this is your Hdfs file system. So what is Hdfs file system? It's a space where you are going to distribute your data into the multiple computer. This is your Hdfs file system. Then you have one more this thing, the processing components, you know, Mapreduce. So Mapreduce is the processing component where you can just run the data that I have stored on in your Hdfs file system. We know that one. This is your Hdfs. Okay, and this is going to be the Mapreducing actually. Okay, so now these are the two components. They were born with our Hadoop when Hadoop was born. We know that one. That part is very clear. But as you know, Mapreduce is a framework. It's a paradigm. It's a technique where you have to take the help of one of the programming language to write your Mapreduce program. It can be Java. It can be Python, it can be Ruby on Rails, it can be C++. One of these programming techniques you have to use in the Mapreduce framework, then only your Mapreduce program is going to work it. As you know, that is the main reason why they had to think the alternative ways to process your data that you have distributed across the HDFS file system, because people who knows about Java and Java kind of technologies in the market are very less actually. So that is the reason people who are already started using almost decade back, when Hadoop was born, when they started using the Mapreduce program, just forget about writing the new programs. People who are just maintaining the existing programs also, okay, they are having lot many challenges actually. For that reason only they just start thinking about the alternative ways here. So one among the solution out of that one is going to be the Hive actually. So Hive is going to just stay on top of the Mapreduce. It's an alternative abstraction which is really built on top of the Mapreduce programming actually. Okay, so now here is Hive is going to be here actually. So now you can see very clearly Hive is going to use two core components. One is going to be the HDFS and as well as the Mapreduce program. So what will happen here is we are going to create one extra layer on top of your HDFS file system. That is the reason we said like it is a data warehousing tool. So basically when we are going to use our warehouse, whenever you just probably you extract from your data from the different databases and you apply some of the transformations, then the final data whatever you see, that is what you are going to dump into your warehouse actually. So once you dump the data into the warehouse, you can just go ahead and create the reports, you can analyze the queries, and you can simply just fire the queries on top of that. You can see lot of insights out of the data actually. Exactly, that is what it is going to provide for us from our big data world. Hive is the one who is going to provide that infrastructure for us actually. So when you are going to put the data here, the data will be again stored in the HDFS file system, but it will be in a structured way actually. It is a kind of the warehouse. Okay, so you have to understand it has to using both HDFS and Mapreduce both for our processing component. The next thing is going to be Hive is same as your SQL. Okay, so Hive is same as SQL. The main intention of introducing the Hive is only people who are having the some of the SQL knowledge, they can go ahead and write the simple Hive queries, then they can be converted into the series of Mapreduce program. These Mapreduce programs are going to work on top of the HDFS file system. That is the real definition of your Hive actually. Hive is a, again I'm repeating here the definition of a Hive. Hive is a data warehousing tool which is built on top of the Hadoop, which can be used as a warehousing from our big data world actually. So Hive is going to use both Mapreduce as well as HDFS, both for its storage purpose, for its processing purpose actually. That is what exactly where Hive is going to lie actually. Let's go ahead and see the next topic actually. Okay, the next thing is going to be, instead of writing the, as you know, that is the definition, instead of writing the complex Mapreduce programs here, simply you are going to write our Hive queries that will be converted into series of Mapreduce program. We have seen with our discussion actually. So in Hadoop we are going to use both storage and as well as processing technologies. We have discussed that one very thoroughly just now. The next thing is going to be, it uses HDFS to store its underlying big data and Mapreduce to process the stored data. That is what exactly we have seen in this diagram actually. HDFS and Mapreduce both will be used for this purpose actually. Okay, the next thing is going to be, who was developed Hive initially? Hive was developed initially the Facebook. They are the one who was started thinking this way, and later on Apache Foundation took as a full-time project, and it named its project name as a Apache Hive actually. So Facebook is the one who has introduced earlier with the Hive actually back in 2007-8. Okay, then Hive architecture. So what Hive is going to follow, and what and all ways we can trigger the Hive queries so that it will work on top of the HDFS file system and the top of the Mapreduce program. So as you know, there are some different ways where you can just trigger your Hive queries. Actually, you can talk to your Hive engine. This is going to be your Hive engine. Basically, this is the Hive core part, this one. So using three ways where you can talk to your Hive. Actually, one is going to be the CLI, command line interface, CLI. So simply you can just go ahead and open one command line interface, and you can just go ahead and key in your queries, and that will be converted into series of Mapreduce program. Or you can just go ahead and use the web interface. Actually, so what I mean by web interface is very simple. You are going to just open one URL, and in that you are going to just put it your queries, and those will be converted into series of Mapreduce program by just sending that one to the this engine. Actually, the third one is going to be the thrift server. So using your JDBC and ODBC remotely, you can just go ahead and fire your queries, and that will be just working on top of the Hive core. Actually, that is going to be the next thing. So these are the three ways where you can just trigger our Hive queries, and you can talk to our Hive engine. So now what is this driver? Actually, driver is the one who is going to play the vital role in our Hive architecture. Actually, driver is the one who is going to interact with our clients. Driver is the one who is going to interact with our Hdfs file system. Driver is the one who is going to interact with our Mapreduce also. So let's go ahead and see how it is going to behave. So driver is the one, first and foremost thing, irrespective of whether you are going to trigger your queries from CLI, from ODBC, JDBC remotely, or probably from your Hive web interface. Irrespective of that, first and foremost thing, the query that you have fired, that will be analyzed, that will be taken care whether is there any user errors in that will be taken care by the parser. Actually, parser is the one who is going to just make it very clean query, whether it is having any syntax error, user error, and once that is passed, that will be passed to the optimizer. Optimizer is the one who is going to, basically when you are going to run as a script, it's going to optimize your query automatically. Optimization is nothing but wherever so some programmers probably, if you have, they have, instead of running your query at the beginning of the stage and you have running at the entire or later stage, if you're running, in that case, instead of just throwing your running your data, flowing your data from top to bottom, basically your optimizer will come into the picture, I would say, in the filters. Actually, so probably out of your 1000 employees, people who are having, just your use case is going to maybe people who are going to be particular location. Actually, but the particular location, out of the 10,000 employees, only 1000 employees are there. But instead of filtering your data in the starting stage, if you are filtering at end, indirectly you are going to just, instead of processing your 1000 records, you are processing the 10,000 records till end. Actually, that is not the good way of doing that one, because your Hive query is going to take more time to process. That is the reason it's going to optimize automatically. Instead of just filtering at the end, you are going to filter at the starting only. That is going to, the optimizer is the one who is going to do. The next thing is going to, it's going to create the execution plan. Actually, the planner is the one who is going to create the one or more their sorted Mapreduce programs, which means how many Mapreduce programs can be triggered on top of this Hive. Actually, based on your Hive query, the nature of the query, whether you are using joins, you are using where clauses, you are using having clauses, all those things, your planner is the one who is going to just trigger, or who is going to decide, okay, these many Mapreduce programs are going to be triggered. Once that is done, we are going to just hand over to the execution engine. Actually, execution engine is the one who is going to create completely the Mapreduce programs, and that will be handed over to the our Hadoop framework. Actually, so whenever I say Hadoop, in the sense, it is going to just trigger whatever the Mapreduce program that we have added, that will be handed over to the resource manager, which means Mapreduce program is nothing but the resource manager. The resource manager is the one who is going to go continue, and it's going to just work on top of the Hdfs file system, whatever we have provided. This is what exactly in our Hive is going to work out. So once you are done with your process, that required output can be again dumped into our another Hive table, or you can just go ahead and store into the Hdfs file system. Actually, okay, this is what exactly it's going to happen in our Hive architecture. And also you can see one more thing here is, as you know, simply what we are going to do, we are going to have our Hdfs layer, right? Hdfs This is your HDFS file system. In top of the HDFS file system, simply you are building one more grid kind of thing actually. Okay, you're going to build one more grid kind of thing, so that this is going to give you the better idea. This is going to give you the clean structure for your data actually. Simply once you put the data into this is called your Hive actually. The creating the grid is nothing but your Hive. On top of the HDFS file system, your underlying data will be stored in your HDFS file system only. Whatever the concepts that you have from the HDFS side, still you can see the same thing. So once you put the data here, you are going to just process the data using your Hive queries actually. That is very simple. Okay, so that is what exactly. But as you know, when you are going to create the databases, when you are going to create the tables, when you are going to create the columns within that one, you have to maintain them in a particular place. The definitions of your databases, your tables and your column names and anything that you are going to store it, you have to maintain it one place. That place only will be calling as a meta store. Meta store is the place where we are going to store the Hive tables definition. That is the kind of metadata how we see from our name node. Exactly we are going to see from the meta store actually. Meta store is the place where we are going to store our entire Hive tables definition. Your meta store can be embedded meta store, which means by default your Apache Hive is going to use the Derby database. You can just go ahead and use that one as a meta store. Or as you know, when you're going to use as a meta store as a Derby database, here there are some limitations actually, where only one person is going to be the only single machine. Only in the entire one machine only you're going to have Hive as well as the Derby database. So Derby database is a RDBMS database. It's a it's a file oriented database. And whenever you're going to use Derby as a database, actually you can open only embedded database indirectly, which means everything is going to run in a single machine. So indirectly you cannot open more than one Hive session actually. If you're trying to open more than one Hive session, you're going to see some error actually. For that you can just go ahead and use the standalone one. What I mean by standalone one is like you are going to separate, you're going to run in a different machine your meta store, and you're going to just do the back and forth whenever you fire the queries. That connection will be made to the meta store. And here, since you're going to separate your meta store out of your this embedded one, obviously in the local we'll be calling as a standalone. Meta store is a standalone. So in that case your query will just be in the touch with your meta store. And also you are going to just, you can open more than one session in parallel actually, which means that the table that you have created, I can access from my side, and the tables which I have created can be accessed by others also. That is all about the meta store. That is the complete architecture of the Hive actually. Okay, and more on Hive actually, and what and all we can see on Hive actually. What are the advantage that we are going to see on top of the Hive actually? So basically Hive is going to accept, or Hive is very well is famous for creating the simple tables. Simple tables are going to give the lot of difference for our Hive actually. When you're going to put the table on top of the Hive warehouse, it's like it's going to just give the, it's a column names, and whatever the primitive data types, whatever the complex data types, you can just go ahead and use them. On top of that one, simply you can just fire the queries that will be converted into the series of Mapreduce programs. So simply you can go ahead and create the tables, and also you can apply the partitions concepts also. What I mean by partitions here is, partitions are nothing but just organizing your table in a structured way, which means, as you know, in the big data world, when you are going to have the data, tons of data you are going to store in a single table, then to just search your data, probably this is the data that I'm going to have, probably last 1 year of data. Out of last 1 year of data from the data source, probably I need only probably last 3 months of data. I'm caring about only last 3 months of data. I don't care about last entire year of data. But using your normal tables, you cannot just process only the 3 months of data. Your search query is going to process from top to bottom actually. Sequentially it's going to happen. But if you are going to apply the partitions concept, you are going to divide your entire data into multiple partitions, and you can just, your query can directly command fire on top of this portion of the data, so that we can unnecessarily, which I don't want to process any unwanted data, which we are going to avoid using the partitions actually. The next thing is buckets, which is very unique concept here. Bucketing is nothing but again dividing your table into equal number of parts, and you are going to store the some amount of data here. So we are going to see some advantages of out of the buckets over the partitions, but you can apply on top of the table, you can apply the partitions, you can apply the buckets also. Buckets are basically is going to follow the hash partitions, which means like if you are going to divide your table into 250 buckets, and which means 250 parts you are divided based on the bucketed column that you are going to store have in that at the time of designing your table. You are going to just see that what is the bucketed column value. Based on that, it's going to perform the hash partitions, and it's going to go and into store into that partition bucket actually. So bucketing is very famous for sampling of your data, which means like instead of processing your entire data, you can just go ahead and sample your data for your probably sampling purpose. You wanted to introduce some of these so and so things, you instead of just searching your query on top of your entire data, even in the partition also, you don't want to go with the entire partition data, you wanted to go with the only portion of the data. In that case, bucketing is going to be very useful for us. And joins, map joins is going to be very famous out of the buckets actually. Using the map joins, using the buckets, you can join your two tables very nicely without triggering the reducer actually. We are going to see all these things in our classes very thoroughly. Okay, and the physical layout, as you know, like I said, end of the day our Hive also is going to store our data in a Hdfs file system. So these are default location of warehouse for our Hive actually, user Hive warehouse. So you can have the different location also, we are going to see in our classes very thoroughly. Okay, and the table data stored in a subdirectories of the Hive. So after this one, whenever you are going to create the database, your database name and your tables name, so your tables name something like that will go on. So you are going to create the subdirectories on top of the Hdfs file system actually. Okay, and the next thing here, your default warehouse location on top of the Hdfs file. This is your Hdfs page, as you know here, and I just browse my file history, and you can see this is where we are going to create the databases. This is my database name, and within that only it has created one directory. This is a directory, you can see this is the directory, and this is the permission, and directory does not have any replication. So whatever the data again you are going to store in your Hdfs file system using your Hive, again the Hdfs, whatever the concepts that you have out of the Hdfs, your Hive data also, Hive tables data also is going to follow the same thing. The replication factor, the block size, and everything will be remains the same thing actually. Okay, thanks for watching this video. See you soon. Thank you. Hi all, thanks for watching this video. Today we are here to discuss about Apache Pig from Big Data Hadoop side actually. Like, so as we know here, we have one ecosystem, or one which was born from Hadoop side. When Hadoop was born, we got one ecosystem that is called Mapreduce, right? Mapreduce is a programming techniques, or it is a framework, or it is a paradigm using which we are going to process the large data sets with the help of Hdfs file system. That is what at the high level information about the Mapreduce program. If you want to know more about the Mapreduce program, please check my other video also here. So here, when we have the Mapreduce program in order to analyze your data on top of your big data, then why we have to use this Apache Pig? Okay, so actually, as you know, Mapreduce is a framework. What I mean by framework here, framework is nothing but you are going to just use, or you have to take the help of one of the programming language in order to develop that framework, develop the technique actually. So Mapreduce itself is not a programming language actually, right? So probably you have to take the help from Java, Python, Perl, or etc. These are the programming language you have to take the help in order to develop your Mapreduce program actually. As you know, people who knows about the Mapreduce program, or people who knows about the Java or Java kind of technology in the market, are very rare. So that is the main reason, right? That is the main reason why this Yahoo, Facebook, all these big organizations started thinking about the alternative abstraction for the Mapreduce program. There is no doubt Mapreduce program is going to work excellent, but the way we are creating, the way we are going to manage them, the way we are going to maintain them between the interfaces is became the difficult part actually. That's one of the challenges our organizations have started facing within 2 years of time. The moment they introduced the Mapreduce program, they started using that for their day-to-day activities. They started seeing the challenges in their production environment. So they started thinking alternatives. Yes, Mapreduce is working fine, but the way we are going to create in order to develop the Mapreduce program, as you know, Mapreduce is the one who is the collection of stages actually, right? So you have to know in and out what is happening in each stage actually. Then only you should able to develop the Mapreduce program, right? Here you can see the simple definition of the number of lines that we are going to end up having the Mapreduce program actually, right? So in order to develop the Mapreduce program, you have to understand what is happening in each and every phase before you are passing the data to the next stage, what has happened in the previous stage, what you are going to achieve in the current stage, and what you are going to pass to the next stage actually. That is what you have to understand very clearly in order to develop the Mapreduce program. So that is one of the challenges that we have from the Mapreducing side. The other one is going to be in terms of, as you know, when you are going to end up having almost 160 of lines to develop the program, obviously you will spend lot of time for that one. The development productivity also you're going to see somewhat less actually. But comparing with this Yahoo, Facebook, these people have started coming up with the alternatives to come up with the Mapreduce program. One among them is going to be the Pig actually. Pig is a alternative abstraction that will be working on top of the Mapreduce program. So what I mean by that one here is Pig is going to be a scripting language which is going to follow the Latin scripting language, and it's very simple, and it's a data flow language. We are going to see very clearly in our classes what is data flow language, right? So using a simple instructions, right? It's not something VB scripting, Java scripting and all. It's very simple, and we are going to learn very clearly in our training, right? Using simple statements, instead of writing the 160 lines of code towards your problem statement that you are going to be completing from the Mapreducing side, we are going to use simple instructions within 5 to 10 lines of code actually. These 10 lines of Pig script only will be converted into series of Mapreduce programs actually. Based on the script, the way you are writing, that will be converted into automatically into the Mapreduce program by the Hadoop or Pig framework actually. You don't have to do anything to convert them actually. The framework is the one, Hadoop or Pig framework is the one who's going to take care for that one actually, right? So instead of writing this lengthy code here, whatever you are seeing on our screen, we can just end up having the 10 lines of code. These 10 lines of code only will be converted into 160 plus lines of Mapreduce program. Who is going to do that one? As a Pig developer, I don't have to know anything about Java or Java kind of technology language in order to just develop that one actually, right? So as all I have to know, like I need to know the Pig Latin scripting language, that's all. So the framework is going to take care of the converting them into the Mapreduce program. So that is the one thing that you have to understand. And also, so the number of lines that you will ended up having to create your Mapreduce program using Java or Java kind of technologies, in terms of minutes, you can see almost 240 plus minutes you are going to take time to complete this number of lines that you ended up having particular problem statement. But using Pig, you will end up having almost within 10 minutes of time you are going to complete the same task actually. So in terms of performance wise, whatever you are going to see out of the Hadoop, you are going to see the same thing using the Pig also. There is no difference in terms of performance, because your Pig is not going to work on top of your Hdfs data. End of the day, your Mapreduce programs only going to work on top of the data, but you as a Pig developer, you are not going to create the Mapreduce program, right? Your framework is the one who is going to create the Mapreduce program for us actually. So that is the difference between in terms of number of lines, or the in terms of code number of lines that will ended up having going with the Mapreduce program. The same problem statement going with the Big, it's going to take very less than whatever we have the number of lines. In terms of development time also, it's going to be the lot of difference between the developing your Mapreduce program than developing the Big script actually. So we are going to see very clearly in depth in our classes, but this is the major difference between the Java versus our Big Latin scripting one actually, right? Let's go ahead and see how the architecture is going to work out actually, right? So all you have to do, you have to write this 10-15 lines of Big scripts based on your problem statement, based on your business requirement, right? So those scripts will be handed over to the Big engine. We'll be calling as a Big engine. Let's go ahead and see one by one how this architecture is going to work, but in depth we are going to discuss again in our classes. But let's go ahead and see, these are the three different ways where you can interact with your Big engine actually. One is going to be simply you're going to write the Big scripts, right, and you're going to just hand over that one to the Big engine. That is one of the way. The other way is going to be Big is going to have its own shell that we are going to call it as a grunt shell. It's an interactive shell. That means like you are going to just have your scripts, then and there it's going to evaluate and it's going to give the output. The Big server, which is remotely you can access this Big engine other than within the cluster. You can just by accessing or by connecting to the Big server, you can remotely using the JDBC connection, you can always send the Big scripts back to the execution engine. So whatever the way that you are going to have, end of the day, each and every, either we are going to run through the grunt shell or Big server or using the Big scripts, the scripts will be parsed, right, which is going to go through one of the stage that is called parser. What is that mean by parser here? So whatever the user error or syntax error those are there in the script, that will be checked then and there. If there is any error in that one, it's going to just show that one back to the user and it's going to be terminated there actually. That is what the parser is going to do. The main purpose of the parser is what? In order to just check your script is syntax free error, right? User error free error actually, right? So you are not going to just, you are going to make sure that there is no syntax error and there is no user errors in that one. So once that is done, Big has the intelligence to optimize the script actually. So what I mean by optimizer here is whatever the filters and whatever the merge, whatever it's going to happen, probably as a programmer, probably you're going to have, or you might have had the script as a filter or as a merge and all in the wrong place, but using this optimizer, automatically our script will be optimized actually. For example, instead of filtering, probably you are just working on top of your employee payroll, people whose age is having greater than 50, out of your probably 1 million records, you have only probably 1000 records people who are having the 50 years old actually, right? So now instead of filtering this data up front, if you are filtering at end of the data on take, then that is going to be your data has to go through each and every stage before you filter out the data. So now instead of processing your 1000 records, you are going to process 1 million records, which is not a good practice actually. So you as a programmer, you don't have to worry about that one. The optimizer is the one who is going to take care of this one. So Big script will be automatically optimized by our Big engine actually, right? The next thing is going to be the compiler. So what I mean by compiler here is going to be whatever the Big scripts, whatever we wrote here, right? So this Big script is the one who will be compiled, which means we are going to convert into the number of Mapreduce programs based on the purely your script actually. Probably your script might be qualifying for 1 Mapreduce program, 2 Mapreduce programs, 3 Mapreduce program, based on the number of stages that you are going to create, or based on the number of sequence of steps that you are going to have within your DAG. You are going to see that number of Mapreduce programs are going to be created. So you are going to see your DAG will be converted into the number of Mapreduce programs, right? So what I mean by DAG, directed acyclic graph, it is a set of your Big statements actually, right? So once the parser is done, that will be added to the DAG actually, right? Your DAG is the one which will be converted into the series of Mapreduce program by the compiler actually. So we are going to discuss more about in this one in our regular classes, right? The next thing is going to be the execution engine, right? Once your compiler has divided and created into the Mapreduce program from your pig scripts, that will be handed over to the pig engine actually. Now pig engine is the one who is going to simply hand it over to the Hadoop, which means your resource manager if you're running in your 2.x and job tracker if you're running in 1.x actually. So once you handed over that one to the Hadoop, which means your resource manager slash job tracker, that flow is completely as usual. So from there onwards, whatever or however we just started creating the flow from there, how the Mapreduce program will be created and will be working on top of our data which is stored in our Hdfs file system, exactly the same way the flow will be continuing from there actually. There is no meaning, there is no change at all from there onwards. So that is the reason one of the advantage using the pig here is you don't have to go ahead and install the pig everywhere in our cluster actually. All you have to install at one place where the is a user or the client machine. There we are going to just install the pig. Then after that everything will be taken care. You don't have to install each and every machine, because end of the day the pig scripts will be converted into the Mapreduce program which is handed over to the Hadoop actually. From there onwards the process is going to be the same thing actually. Okay, so you can see very clearly in our next slide, we can see very clearly this is how the pig Latin scripts are going to be actually. We are going to discuss very clearly line by line in our training. Okay, so once you develop your pig scripts, that will be parsed and that will be checking the syntax errors and the user errors and all, and it's going to optimized, and we are going to create the execution plan. This is where the compiler will come into the picture actually, right? You're going to create the execution plan which is going to have the number of Mapreduce programs, how many mappers that you're going to trigger, how many reducers you are going to trigger. All these things will be created out of this compiler. So once that is done, it will be handed over to the pig engine, which is just indirectly handed over to the Hadoop. So once you handed over to the Hadoop, that's what you are going to see, like job tracker or slash resource manager is the one who is going to take care of completely from there the Mapreduce program. Okay, so that's all we have on this pig. Thank you so much for watching this video. Please subscribe or just to follow on this channel for more videos from the Big Data Hadoop actually. Thank you so much.